3. I/ATLAS, the 10th anomaly, the 4 arcseconds that break physics, October 30th, 2025. Atacama Desert, Chile. The ALMA array didn't just track 3 I/ATLAS, it caught it lying. As the interstellar object emerged from solar conjunction, ALMA's millimeter wave eyes locked onto its position with micro-arc-second precision. The result? 4 arc-seconds off from its predicted gravitational trajectory. In cosmic terms, that's a continent's width at interplanetary scale. "This isn't noise," said Dr. Sofia Ruiz, ALMA's lead astrometrist. "This is acceleration. Something pushed it. But comets accelerate by losing mass. Sublimating ice creates thrust like a rocket." The math is ironclad. To produce 4 arcseconds of deviation at one point, 4 astronomical units, 3 I/ATLAS must have shed over 5 billion tons of material, 15% of its total mass. Yet, no debris cloud. Hubble saw nothing. JWST saw nothing. Even ALMA's deep scans found no dust trail, no gas plume, no expanding shell. "It's accelerating," Ruiz told Avi Loeb in a secure call. "But it's not losing mass. That violates conservation of momentum. It's like a car speeding up without burning fuel." Loeb was silent for 10 seconds. Then it's not a car. It's something else. For the first time, Loeb allowed himself to say it aloud. This could be the 10th anomaly. And if confirmed on December 19th, humanity would face a choice: rewrite physics, or accept extraterrestrial engineering. The missing cloud. November 5th, 2025. Global Observatory Network. The scientific community split into 2 camps. Team Natural. "The cloud is there. We just can't see it yet. Maybe the dust is too fine. Maybe it's aligned edge on. Give it time." Team Anomaly. "If 5 billion tons vanished, it would scatter sunlight like a fog bank. At 1 astronomical unit, it would be brighter than Venus. We'd see it with binoculars." Loeb refused to choose sides. Instead, he designed a test. Using the sun's gravity as a lens, Einstein's gift to astronomy, he calculated that light from 3 I/ATLAS would be deflected by 0.27 arcseconds as it passed near the solar limb. That tiny bend could reveal surface details or hidden structure, but more crucially, any debris cloud would distort that lensing pattern, like ripples in a pond. "If there's a cloud," Loeb explained in a Harvard seminar, "the lensed image will be smeared. If it's clean." The object accelerated without ejecting mass. NASA approved emergency time on Hubble to capture the lensed light. ESA tasked Gaia with ultra-precise astrometry. China's FAST array listened for dust impacts. And the world waited. Because by December 19th, when 3 I/ATLAS passed 269 million kilometers from Earth, every telescope would see the same thing: a cloud, or silence. And silence in science can be the loudest evidence of all. The retrograde lie, November 12th, 2025. Cambridge, Massachusetts. Loeb stood before a star map, tracing 3 I/ATLAS's path with a laser pointer. "Look at this," he said to his team. "It's moving retrograde, opposite to the planets. That alone is rare, but not impossible. Interstellar objects can come from any direction." He paused, then zoomed in. "But it's also aligned to within 5 degrees of the ecliptic plane." He turned to face them. "Imagine throwing a boomerang backward and having it curve perfectly into a hallway you've never seen. The odds? 0.2%. The room was silent. Because retrograde motion suggests random origin. Ecliptic alignment suggests deliberate navigation. You can't have both unless the object changed its mind after arrival, or unless it knew the layout before it came. "This isn't drift," Loeb said. Its reconnaissance. It approached from a random vector to avoid detection, then aligned with the planetary plane to observe efficiently. Critics called it anthropomorphism. But the data didn't care. Sunward jet defies physics. Nickel-rich, water-poor, industrial, bluer than the sun, hotter than stellar surface. Now, acceleration without mass loss. Each anomaly alone could be disputed. Together, they formed a chain no natural process could support. And on December the 19th, the chain would either break or become a bridge to something unimaginable. Loeb closed his laptop. "We're not just testing a comet," he said. "We're testing reality itself." The global eye opens December 1st, 2025, worldwide. The countdown had begun, 18 days to December 19th. For the first time in history, humanity's greatest observatories synchronized not for a supernova, not for a black hole, but for a single, speeding object in the outer solar system. Hubble powered up its WFC-3, calibrated for ultra-deep debris detection. JWST angled its sunshield to capture mid-infrared dust signatures. ALMA arrayed its 66 dishes into a single Earth-sized telescope, tuned to submillimeter dust grains. Keck, VLT, and Subaru activated adaptive optics to resolve structures down to 50 kilometers at 1 astronomical unit. Arecibo's virtual network, now a distributed array across 12 countries, listened for meteoroid impacts on an invisible cloud. Even amateur astronomers joined, over 20,000 registered observers submitting photometry to the Global Atlas Watch portal. At Harvard, Avi Loeb convened the final pre-observation briefing. "If the cloud exists," he said, "we see scattered light, thermal emission, and radar echoes. It will be unmistakable." He paused. "If it doesn't, we face a new law of physics, or a new kind of intelligence." NASA issued a rare public statement. On December 19th, all raw data will be streamed live. No filters, no delays. The world will see what we see. It was a gamble, but Loeb knew truth cannot be classified.